So I know you think I'm crazy because I like derivatives. You think, oh my goodness, that is so much work finding the limit with a difference quotient, blah, 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 all the time. Well, guess what? Just made it easier for you because I'm going to show you a couple of rules and a couple of derivatives that we kind of have to, I don't want to say memorize, but we need to know for a future. So it kind of helps you out without having to find the limit every single time, and we just kind of roll with it. So here's what I'm going to do. I'm going to just go through here and I'm just going to talk my way through it as I talk about the derivative. And let's see if you think you can come up with the derivative or for the power rule. We look at these polynomials. So the function is of f of x is going to be 3x squared minus 2x plus 3. The derivative f prime of x is going to be 6x minus 2. Okay. If our function is negative 5x to the third plus 2x squared minus 3x plus 1, then the derivative of that is going to be negative 15x squared plus 4x minus 3. Okay. Here's a crazy one. It has some rational exponents. So we have 6x to the 3 halves plus 4x to the negative 2. So that derivative is going to be 9x to the 1 half minus 8x to the negative 3. Okay. Last one, negative 6x to the negative 1 half plus 3x to the positive 1 half. So the derivative of that is going to be 3x to the negative 3 halves plus 3 halves x to the negative 1 half. All right. So did you catch my pattern? So here's what happens. I'm going to take the exponent of the x, multiply it by the coefficient, and then knock down that power by 1 every time. So that's the power rule. So the d over dx. So this is the derivative with respect to x. So you'll need to know this. We're going to use this later on. But the derivative with respect to x of x raised to any power of n is going to be n times x to the n minus 1 power. So I'm going to take that the exponent, multiply it by the coefficient. This time the coefficient of x is just 1. So that's when we're just left with n. And then times x to the n, and I'm going to knock down that power by 1 for every derivative that we have to take. So that's the power rule. The constant rule, basically when f of x is equal to any constant, so 5, 7, 322. So what's the slope of that tangent line? Well, the slope of a horizontal tangent line is always going to be the same, and it's always going to be 0. Okay, so there's those two rules. Boom, bing, got it. So that's why you can see, like on this first one, we dropped this plus 3 because the slope of that, the slope of just the plus 3 part. So we take the derivative, the first piece and the second piece and the third piece, and you just keep going on and on when you add and subtract. Multiplying, different story. But when you add and subtract, you can do that. So let's take a look here. We're going to find the derivative of these functions here. Woohoo! It's going to be so fun. So what I want to do here is I'm going to go ahead and rewrite this without the denominator there. So I'm going to write this as, so f of x is really going to be 2x to the negative 2 minus 4x to the third. Okay, so that just helps us out a little bit. So f prime of x is going to be negative 4x to the negative 3 minus 4x to the 2. Ooh, whoa, hold up. That's going to be 12x squared. So what we have here, so this really ends up, so now we're going to do some simplification here. So negative 4 over x to the positive 3. So remember, we have a negative exponent. I have to knock it down to make it positive. Minus 12x to the squared. So to get the common denominator, I'm going to have to multiply this by x squared, or x to the third over x to the third. So I end up with negative 4 minus 12x to the fifth, all divided by x to the third. Just a little bit, that looks a little bit better. All right, so if f of x is this polynomial divided by x, what you'll notice is that I could technically go ahead and factor out an x and then go through and divide it out, but I can just divide it out here. So this knocks this down to 1, knocks this down to 3. So really, f of x is equal to 3x to the third minus 3x minus 2. So now I'm going to find the derivative of that. It's a little bit easier. So remember, I'm going to take this coefficient, this exponent, multiply it by this coefficient. That's going to become 9x, and I'm going to take 3 and knock it down by 1. So therefore, I'm going to have 9x squared minus, and then we have 3x. So I'm going to multiply this coefficient. It's a 1. So 1 times 3. That's going to be 3. And then I'm going to knock down the 1 down by 1, which is going to be 0. So you just leave it 9x squared minus 3. All right, so here's what we're going to do on these next two. I'm going to find the equation of we're going to have f prime of x, so that's going to be the derivative for any value of that I want, that I need, and then I'm going to find the equation of the line that is at x equals -1, the equation of the tangent line, excuse me. Okay, so let's go. What I want to do here is go ahead and multiply out, so I have f. So just regular f of x. So I'm not even going to start trying to find the derivative until I can have this a nice, pretty polynomial. So this is x squared plus 5x plus 6, all multiplied by 2x plus 1. And then this becomes 2x to the third plus x squared plus 10x squared plus 5x plus 12x plus 6. And then I'm going to combine terms. This doesn't have one to go with it. So I have 2x to the third, and then I have x squared and 10x squared. These are going to make 11x squared. And then I'm going to have 5x and 12x. That makes 17x. And then plus 6. So this is f of x. So now I can use the power rule to find f prime of x. So f prime of x is going to be 3 times 2, which is 6x squared. Because I'm going to knock that exponent down by 1. Then I'm going to take my exponent, multiply by 11. I'm going to get 22x. And then and that knocks it down, and then plus 17. So that is going to be the equation of the slope of the tangent line. So if I want to find that at x equals -1, I need to find, so the point of tangency is going to be just f of -1. So what is that y value going to be? Well, that's going to be -1 plus 3 times -1 plus 2 times 2 times -1 plus 1, which ends up being 2 times 1 times -1, which is -2. So my point of tangency is going to be at -1. I get that from here. And then my y value is going to be here at -2. Then the slope of tangency is going to be f prime at my f prime of -1. So I'm going to use my derivative. So it's going to be 6 times -1 plus 22 times -1 plus 17. And that is going to give me a 1. And then I am going to end up, so this is the slope. So this is basically m. So to find the equation, it's going to be y plus 1 is equal to the slope, which is 1, or not to have it, times x. Ooh, whoa, hold up. Hold the phone. Okay, hang on just a second. This is supposed to be y plus 2, excuse me. And this is x plus 1. Sorry about that. So that is the equation of the line, of the tangent line at x equals -1. All right, so this one is kind of tricky. So what I want to do is I want to go ahead and rewrite this denominator with a negative exponent and negative rational exponent, really. So this is going to be 3x times x to the -2/3, which really ends up being 3x to the positive 1/3, because this is like a 1. So remember, you add the exponents. So 1 plus -2/3 is going to be a positive 1/3. So therefore, what happens when I use the power rule to find the derivative, I'm going to take 1/3 times 3. That's going to make a 1. Or you don't have to write it. And then x, and then I'm going to knock down 1/3 by 1. So basically, I'm going to subtract 3/3 from there. That's going to be a -2/3. So this ends up being 1 divided by the cube root of x squared. I don't know that it always ends up being that. Maybe it does. We'll see. So now I'm going to change this. I'm going to find the slope of the tangent line at x equals 8. I did that because it's really nice and pretty. So remember, the point of tangency is going to be at 8 something. I need to find that something. So that's going to be f of 8 is going to help me find that something. So I have 3 times 8 divided by the cube root of 8 squared, which ends up being 6. So my point of tangency is going to be at 8, 6. Now I need to find the slope of tangency. So I'm going to find f prime of 8. So f prime is 1 divided by the cube root of 8 squared, which ends up being 1/4. Now I can go in and make my equation, because this is my m. M. So I have y minus 6 is equal to 1/4 times x minus 8. So that's the equation of the line, of the tangent line at x equals 8. Last example here, what are the at what values of x will the function f of x equals x to the 3rd plus x have a horizontal tangent? So first of all, let's just make sure that we note that the horizontal tangent means that the derivative is going to be 0, because remember, that's a slope of the tangent. So the slope of the tangent has to be 0 in order for it to be a horizontal line. So let's just make sure we note that. Which also means we're going to have a max or min there. So remember, we talked about that. When the derivative is 0, you have a relative max or min. So let's find f prime of x first. So f prime of x is going to be 3x squared plus 1. So we want to find out, when is that going to be 0? So in order for I have a horizontal tangent line, f prime of x has to be 0. So this is great for open-ended questions. So and the free response. So you want to make sure that you note that you know that the horizontal tangent line means that f prime of x is going to be equal to 0, and you know it's going to be a max or a min. So Solving from here, I'm going to subtract 1 from each side. Hopefully you can already see where we're going here. So it's negative 1/3 is equal to x squared. Then you take the square root. So this has no solution. Okay, so what does that really mean as far as, I'm trying to find horizontal, like there's no horizontal tangent slopes or what? Exactly. There's no max or min because there's no horizontal tangent lines because when we set this equal to 0, there weren't any values of x. So this is how you would want to word that. So since f prime of x does not equal 0 at any value, then f of x never has a horizontal tangent line. That's how you would want to word that. So power rule, remember, and then the constant rule, you're just going to take, so the power rule, remember, you take the exponent, multiply it by the coefficient, then you knock it down 1. Even if you have a rational exponent, you still do that. Or if you need to, go ahead and rewrite it even with negative exponents, and then at the end kind of smooth out everything and make it look nice and pretty again, especially for multiple choice. Free response, leave it unless they tell you otherwise. Go ahead and leave it because you don't want any simplification errors. So that's it. And so for power rule, woohoo, I'm excited because it's starting to get really, really, really fun. I promise it's going to be really fun.